This video is still regarding polynomial, and in this third video about polynomial degree, we are going to find out how to determine the degree of a polynomial given the table. You may have learned this in Algebra 1 or maybe Algebra 2. You have to check successive differences, which means as x changes about the same values, how the y value changes. And the number of successive differences needed for the differences to be constant is equal to the degree of the polynomial. So you have to keep checking. So for example, here you are subtracting -1, then you are adding 2, then you are adding 5, and here you are adding 8. So now let's check here. -1 to 2, I'm adding 3. 2 to 5, adding 3. And 5 to 8 is also adding 3. So now this difference is constant. So what's the degree of this f of x? So you can say the second difference is constant. So n is equal to 2 because second difference is constant, which means this is a quadratic function, f of x. Now, don't forget to check here also. Sometimes they trick you. So this is, of course, the same. Let's check here, 0, 3, 6, 9, 12. So clearly this side is added 3. On this side, see -2 to 2. So you are adding 2. You are adding 8. Adding 7. No, 10. What the heck? Adding 10. 0 to 10. 10. 17. And 23. So now 2 to 10 is being added 8. You are adding 7. You are adding 6. So now difference is 1. So first difference, second difference, third difference is constant. So n is a 3, which means g of x is a cubic function. This is very typical in a AP exam as well as in the assessment. All you have to check is the degree. Later on, you will have to check, given the table, is it exponential, quadratic, log, or polynomial. Right now, we are only dealing with polynomial, but get familiar with the concept, how to find the function. Is it, which degree is it, or which type of function? You must know the pattern. Now, the second part of this is we are going to talk about odd and even functions, which you have learned many times in Algebra 1 as well as Algebra 2. So, even function means if you have a point x and y, you must have a matching point -x and y, which means if you replace x with a -x, y value is the same. So if you have a point in a first quadrant, you must have in a matching point in a second quadrant. If you have something here, you must have something here to do the matching. So remember, even function means the same y value, x is replaced by -x. Odd function means if I have a x and y here, then -x will give you -y, which means again, if you replace the x with the -x, the graph is flipped 180 degrees. You can say that you switch the graph 180 degrees, and that makes it odd function. In other words, if you replace x with a -x, y value is also negative, and that makes it odd function. So from the graph, you can easily see that this is a even function, because if I have something here, I have a matching piece here. If I have something here, I have a matching piece here. So this is the even function example. And odd function is you have here, the matching is here. And also you can say flip 180 degree. It looks same. Looks same. That from the graph, it's so much easier. Okay, so now how do you do from the given the equation? Many students are making mistakes that this is a fourth power, so that's why it's an even function. This is a third power, that's why it's odd. That is not true. That is not true. You must test the values. So let's find h of 1. Check. 2, 1 to the fourth is 1. 1 square is also 1. And 5. So you will have 2 minus 1 plus 5, which is 6. Now let's check h of negative 1. 2, negative 1 to the fourth power, negative 1 to the second power, plus 5. So that will give you, because second power and fourth power makes it positive, and you get the same y value for the negative x. So that's why this is a even function. Sometimes we use the value of h of x. So I'm going to show you another way to do this also. So replace with negative x, which is 2 times negative x to the 4 minus negative x to the second plus 5. Negative x to the fourth power becomes positive. Negative x to the second is also positive. And this is the same as h of x. That's why this is even function. You can do the generic negative x, or you can use the number. So let's do this k of negative x, which means negative x to the third power, 3 times negative x minus 1. Negative number to the third power is negative. Now, how do you know this is opposite? So x, check every term. This is opposite. This is also opposite. But this is the same, which means this is not odd, not even. This is a neither. This is how you are using the generic values. If you want to use the number, then also you can do it. You can test the values with a negative 1 and 1. So if you get different numbers, which means there is no connection between 1 and, that's why it is a neither. You have to have a supporting work. You cannot just do the guess and check. You have to show either number or the generic values of x. Now from the graph, again, it's easier to see. This is an odd function because you have a matching values, matching here, let's say here. 2 is negative 2, matching. That's why clearly odd, or you can show the value. Let's talk about it. Parabolas, if it is a normal parent function parabola, they are always even, but this is the shifted parabola. So that's why it's neither. You can say f of 1 is negative 3, but f of negative 1 is a 1. They are not same. That's why it's neither. So odd and even function topic you have already learned many times before. It's just that we are revisiting and making sure that you are showing supporting work.